This is a lesson on reaction quotients. Reaction quotients have an abbreviation of Q as opposed to KEQ. What this is a test case. The main difference between KSP or KEQ and Q is Q may or may not be at equilibrium. KEQ is at equilibrium. You set it up the math exactly the same as KEQ, so the math is the same. Products over reactants, coefficients, multiply only. Exactly the same that we did in the other cases, except in this case, you have all the variables. You won't have any unknown. So you're just testing it to see if it's greater than, equal to, or less than. For example, nitrogen plus 3 hydrogen, equilibrium with 2 ammonia. So write the Q, which is exactly the same thing as KEQ, right over left, NH3 squared N2 H2 cubed. That's what Q is, and so you just test to see if KEQ is equal to Q, if KEQ is greater than Q, or if KEQ is less than Q. So you just plug the numbers in. So for example, you're given that the KEQ is equal to 9, that the ammonia is 3 molar, that the nitrogen is 2 molar, and the hydrogen is, nitrogen is 1 molar, and the hydrogen is 1 molar. And the question is this in equilibrium? Well, you plug the numbers in and compare. KEQ, they tell you, is 9.0, 3.0 squared, 1.0 times 1.0 cubed. Does that equal? So you do the math and you find out that 9.0 and 9.0, yes, they are equal. So you can say this situation up here is at equilibrium. Equilibrium does exist. Okay, here's another example. Same situation. KEQ equals 9.0. The ammonia is 3.0 molar. The nitrogen gas, 1.0 molar. But this time, let's have the hydrogen gas be 2.0 molar. When you plug that in, 9.0, how does that compare to 3.0 squared, 1.0, and 2.0 cubed? Well, that's 9 over 8, so that means it's greater than. If that's true, what happened? Well, we put more stuff on the, we doubled the hydrogen. Hydrogen's over here. So you have too much on this side. So the only way that this can go is for you to use up some of the reactants and make more products. So that means it's going to shift to the right. This You can shift to the right if you need more products. You can also shift to the left if it needs more reactants. Notice the inequality sign? It points to the right. Which way does it shift? Shift right. If you had a situation where the KEQ is less than the Q, then it shifts to the left because the inequality sign points to the left. KEQ greater than Q, shift right, and KEQ equals Q, equilibrium. And that's all there is to this lesson.